Okay, cool. We are streaming now. Okay, so what do we got here? Um, we have some very basic structure transforms, nothing exciting yet, but we're going to be starting to add some randomness into this. Um, we have a list here of currently one item each, one list for the structure, one list for the coloring, and these are lists of transformers that change the template in some way. So you can see here I'm not adding any randomness. Um, we get a source of randomness. I'm just passing that back. We would usually pass back whatever is remaining, but I haven't consumed any of that here. Same here. We get the source in, but I just make it a constant red and then pass back the source. So what we see here is just the nose bridge essentially of this creature we'll be creating. And yeah, I'm going to send some messages out about the stream and then we'll get started here. All right. So I actually want to add some points in here first. So we want to go from the crown. That's one more value we have in here. And then I want to end, there's a few more nose. This nose mid and nose bottom. Those are all around the tip of the nose. And then what we want to do is instead of putting points here, we're going to actually consume some randomness here. Yeah. So I think that if I go to binary source, we have some consume. We can get an int with a max. We have this consume vector div neg to 1, neg 1 to 1, so that gives us not exactly a unit vector, but a vector that is pointing sort of in a random direction. And each dimension is between -1 and 1. I probably need to build up something else, an alternative to this, because what I want to do here is get some random points, but within a certain range. You know, the crown should generally be above. Obviously, it should be near the top. So I'm just wondering how to do that. I mean, what I could do is take this and manipulate that, scale it and stuff, but that just seems a little painful. So well, let's think about with the crown. Let's just write maybe some pseudocode. So we want the x to be, now the x, the way I'm defining these is if you look out of your own face, then x will be to the right, y would be up, and z will be out. And that's how we define the points for the face. And we're defining just half of the face, and then we copy a lot of the points over elsewhere in the code. So when I'm choosing the x of the crown, in fact, maybe I will I wish I had the MetaMask Fox to point to. Actually, I should have a picture. Let me see. Screenshot. Just hold on a second. Okay, so if I go to this guy, so this was the sort of an older rendering. I was playing with a bit of randomness, but mostly defining everything. The crown point is the where the ear meets the top there. So it's called the crown, but it's just the first side of the crown. And what we're going to be defining here in this first transform is just this whole middle line. It's kind of hard to point with all these guys moving around. Maybe I should have gotten a still picture. But from the crown to this forehead, to the nose, to the tip of the nose, and then to this sort of the bottom tip of the nose. And if you look, you can see there's 3 points on the nose, and that again corresponds to these 3. So for the crown, we want the x to be, well, not less than 0, because we don't want the crown to go to, we don't want that point to go to the left, right? We want it, or I should say that, we don't want it to go to the wrong direction. We want that point to be on the Nym's right or our left. Well, either way, it doesn't really matter because it gets copied over symmetrically. But the point is, we don't want it to be less than 0 because this point should be on the correct side to be copied over. And would it be okay if the crown is at 0? I think so. I think that would make all these still look all right. So then we can say x is 0 to, I'm also just assuming that 1 is the furthest out in any direction. So 1 would be to the furthest we want the side of the face to be, 1x that is. Y being 1 would be the furthest up, and y being -1 would be the furthest down, and then z being 1 would be the furthest out we'd like. So the longest nose, you can sort of think of that. So that's what I'm thinking. That's what these units sort of represent. So the crown, we don't want it to be 1. That would be way too far out. But maybe we can make it. Let's do 0.5. It might be a bit much, but we can always tone that back. Okay. Y is how far up on the face. Now the crown. It's going to be pretty far up, but we want room for the ears as well. So we don't want the max to be 1. We want the max to be maybe 0.7. And then the minimum to be, let's say 0.4. Remember, 0 will be in the middle. Negative numbers would be below, below the middle point. And then z will be, that's how far forward. Now the crown is pretty far back. I think we want to keep it pretty far back. In fact, we might not even make any randomness here because that should always be the furthest back point, right? So maybe we'll just make this 0. Okay, now we need to think, okay, how are we going to get this from randomness? I'm sort of thinking what we could do is we could define a function to take 2 vectors, sort of a min and a max, and say, give me a point in that box. So let me just try to write that quickly. Consume vector from what? From box? From bounds, I think it's better. And as usual, we're going to take an int that's going to specify how much bits per component we're going to consume. And we, of course, need the AB vector 3 and the remaining binary source. The reason these are maybes is because we need to deal with the case where binary source is negative. I mean, there's not much left. There's not enough left, rather. Okay, bits per component source. So it'll probably be quite similar to this. We will probably still start with this consume float 0 to 1. That's just a really nice way to start. We might just do this 3 times. Yeah, in fact, let's just copy all this and modify this. It's going to be very similar. So we consume a float. And this also returns a maybe for the same reason. So maybe and then, and we get this x. And then we get a source 1, and we pass the source 1 along, we get a source 2 and a y, and same thing, source 3 and a z. And we're going to return source 3 as the remaining source. But we're going to do something differently here. So here we say vector 3 x, y, z scale by 2 minus the vector of 1. That's what gets us this particular vector. Now, instead, we are going to, let me think here. I have a scale by vector. So, we're going to just define bounds dimensions. And this is going to be the, oh, hold on, we need a lot more in here. We need to actually take in the bounds. Bits per component, and then we need, vector 3, and that's going to be bound start, bounds end should be, whoops, I don't need that there. Bounds dimensions then is, oops, I think minus, yeah. And in a way this isn't dimensions because this could turn out to be negative. I just wonder if there's a better bounds, maybe just bounds space. Whoops. I put that there for lack of a better one. And then what we can do is we can scale this xyz, which will be a max of 1 in each case. Vector 3 dot scale by vector bounds space. Okay, now we have a vector that the xyz is within the range of this bounds space. And then we just need to add the bound start. Vector 3 dot plus bounds start, and then we can take out all the rest of this. That should do it, and I save. I don't get any errors. That's nice. Okay. And let's just then expose this. Okay, and then we can go into transforms and we can actually use this. So, equals, okay, I'm going to say okay because we don't, well, we will have a maybe coming back. We'll turn that into a result. So, all right, that was binary source dot consume vector from bounds, and then with bits per entropy. Let's just say 2. Sorry, bits per component. And we can change that later if we want, but 2 is fine for now. And then we need the dimension box. And that is going to be, basically it's going to come from this right here. So let's say vector 3, and we need the x, which is, it's going to be 2 vector 3's actually. So vector 3 and then xyz, so that's 0, 0.40. Vector 3, whoops, 0.5, 0.7, and 0. Okay. Now, I wonder if this 0 to 0 is going to fuck anything up. Let's go look. some errors here, but we're not done there yet. We don't divide anything, do we? Let's see, bounds end, which is minus. So that will end up with a 0 in the z. Scale by vector, I think that will be fine with the 0. Yes, it just multiplies. Okay. Just want to make sure. Okay, let's do this. Let's comment these out and save and just see if that works first of all. Oh, it doesn't work. We need to turn this maybe into a result. So result.from maybe, and we can give a message, or the error, which if we look at, I think it's in types, not enough source, because we know that if this comes back with a maybe, it means that there was not enough source. Enough source. Why didn't that work? Binaries. The argument is, oh, yeah, we need to give it the source. I guess we can put that here, which actually means, yeah, that's not going to work, because this actually returns, if we look at it, returns the vector and the remaining source. We need to handle that. So, I hope this doesn't get too verbose here, handling all these maybes and remaining sources. We could maybe use a function to, like, I don't know, do a batch call and get the remaining source. But let me not worry about that for now. So then we can take all this. Yeah, we'll do this. Can actually change this one to crown result, because that will be a result here in a moment. And now this returns a maybe. We're trying to get two actual values out of it. We got to do a maybe dot, I guess. We want a with default. And then we say error not enough source as the crown result, and the source one will just be source. And okay, almost, maybe. What's wrong here now? Maybe vector 3. It's it's piping it to a function that expects. Okay, this returns a maybe vector 3 binary source, and I'm trying to write. I might need to be so this returns a maybe vector 3 binary source. But what I want to get is I want to take that maybe, turn it into a result, and put it in the first of that tuple. Okay, let's start out with some case. We might be able to make it more concise, but for now, case all this of, let's just get this to format. Okay, so that works. So we're saying do this, and if it's a just, meaning it works, then make it OKC and S, and if it's a nothing, make the error. So I think there's got to be a way I can make this more concise, and I think it has to do with maybe the extract or unpack. Let's see what comes up. What do we have? Let's see what's maybe extra. Unpack. Unpack and unwrap. So give a function that says what to do if the input is just and if it is nothing. Maybe we could do some maybe.maps just to keep it familiar. Okay, so now we can start the reactor. And see if this does what we want it to. We're not drawing the crown yet. I need to go fix that. I disabled a lot of code to sort of start from scratch here. So if we go to, it should be a Nym, yes, all this commented out stuff. That can actually just be taken away completely. We don't need that. We have the nose bridge, nose front. We don't have the forehead and the crown. So let's let's turn this crown on. I think if we do this, and that, save. Yes, I think I hamstrung the. Wait, so what's going on then? What was that even? Fuck. Okay, what's the problem now? Oh, I need to make these results. Yes, okay. Do something similar to here. And the points we'll need is the inner temple. Yeah, we'll need to define that one too. We'll get there. So it's actually just the 2 there. Then give this a name of crown. Then we just go here. I'm using crown twice. Oh, yeah. Yes. Let's make this crown point. Oh, and that shouldn't have been. And then we need to do this. Okay, and then mirror point. Why is this not working? The argument is that should be a these are all vector 3s. Point 3D. Yeah, but then why does that work here? Nose top is a vector 3. Nym template structure inner brow a vector 3. Is crown not a vector 3? It's not. Wait, it needs the second argument to be. Ah. Yes, I need to do this and not scene 3D quad. You do my own quad. Okay, there we go. Okay, that's going without errors. At least in the Elm code, we will probably see errors now in the demo because I think I still have some points undefined. Oops. Let's see what the console says. Entity crown failed, not yet set. Okay, it's not really telling me exactly what's not yet set, but that's not surprising. So that will probably be, where'd it go? I should move this up too. Because we're using the crown point, but the inner temple we have not yet defined, so we just need to go and define that. If we look at that GIF again, inner temple, that'll be that point right there, the top of that red square. So just for a quick, let's just make this something simple. Let's make it like between these two vectors. So that would be 0.2, 0. Let's say 5 and 0. But we actually do want it to be further out on the z. We actually want it to be lower too in the y. So let's make this, let's make it 0.4. And let's make it 0.4. Okay, and let's see if that fixes the demo. Oh, there we go. So now we have differently colored brows, essentially. Okay, cool. We can also just draw the next piece. Now we do see that there's a color not yet set. But before getting to that, let's just connect these two, which is just going to be uncommenting some code in Nym. That'll be the forehead. It's right here. Let's move that up and uncomment this. And oop, that didn't work. Oh, I need to take out this. There we go. Now we do the same thing here. This takes forehead, inner temple, inner brow. Are those all defined? Forehead point is not. Oh, that's the coloring. No, that's fine. Inner temple and inner brow are defined. Okay. So once again, we're going to result map to. Result.map. Oops. We're also going to change that. We'll get to it in a second. Okay, now this time I'm not going to change the coloring there. Just do this. Okay, and then default and log entity error, and we're going to call this one forehead. And then we need to do this as well. So this function just does that. This function basically calls the material.color if it's a just value, or if it's what is this? This is a result. So if it's an OK value, it does the material.color, and if it's not OK, it defaults to black and then logs the error. Okay, let's see. That's pretty quick to set up. Okay, so now there we go. We have, this is the structure of the brow and the nose. Where that red ends, that's the nose tip, top nose tip. Yeah, I'll get to the color in a moment. I first just want to complete the whole strip down the middle. So that is just going to now incorporate the nose. You can see it's reporting that now we have some colors that are not yet set, so that's nice. The error reporting is working well. So what do we want to do next? We want to do the nose next. Nose front. This looks like it was disconnected from its. Where did the comments below that go? Let's find out. Oop. Nose front is that stuff. Okay, let's just watch that. It's right there. That makes sense. Okay. Let's take this, bring it up here. On comment, take out this scene 3D nothing and do that. And once again, we're going to do all this stuff. Hopefully I'll get fast at this. I think we're just mapping to top and mid. Yep. Although really we could combine this with the nose. There's another one here, I believe. So if we look at this, oh, the nose front is black, and then that next bottom one is gray. So I guess let's not group those. Let's just do how we were going to do here. Okay, map 2, we have nose top and nose mid. Move this down. And then this is going to be meter quad. This is all going to be like this. And then we're going to take these two guys, put them here. And then we're going to map it. Do this. And it's going to be nose front. And then we're going to go do that. And also just for consistency, let's take this, put it here. And we're making it black. Okay, that's interesting. We're not just hard coding that, but it's the nose. I guess that's fine. I don't know if we want the nose to be any color other than black. Okay, well that was easy. Let's see if that gets drawn. Right, probably still need to enable the drawing code itself. So, no, but that is it. What's going on here? Is it being used anywhere? It's being grouped there. Let's see what any errors. Entity nose front failed, not yet set. Oh, did we not? Yeah, we didn't actually put it in here yet. We have nose top, but not nose mid. That's the problem. Okay. Now we will add more randomness here, but let's just get this thing displaying first. Nose top can be just like nose mid, but or vice versa, but the nose mid's going to be a little lower, so let's make that 0.3, negative 0.3 in the Y, and C. Okay, got a little nose now. And let's go ahead and throw this guy in here too. Let's make this very much the same, but let's make it a little slightly further down and a little further back as well. So let's go get that displaying. Nose side, lower snout, temple, ear, cheek. Oh, you know, this is probably the chin actually, because I think the chin is that gray underside. Okay, let's get all that displaying. Chin strip, it's going to be all this. This might be a little more complicated to get working with the new structure, but let's see. So here we're setting the chin strip color to basically, we're darkening that color here. That's why we have the white on the side, that's the chin strip color, and then the gray on the bottom. That is a nice effect. Don't want to really take that out, but what I will do is this is a result.map, because anything in the template is a result. And it might be an OK and it might be an error, so that's an easy way to fix that. Now here, I think we're going to do a result map for this whole thing. We have a nose top, nose mid, nose bottom, and outer bottom snout. So that's result.map for. Let's just pick these guys. Mid, nose top, nose mid, nose bottom, and that. Take that like that. Oops. That. We're also going to take this, that, and that. Take them. Pass them in here. Result, no, that's the default. Yes, and we're going to call this chin strip. And does this auto format yet? It does. And then we just need to go here and here. Actually, first let's fix these. There we go, and that'll make this next step easier. Oops. What the fuck is the problem with mirror point? This happened last time too. I'm forgetting what the issue. Oh yes, these all need to be meter quad. And then here we just need to do this. There too. And here. Okay. Are we not displaying the chin strip yet? Probably not. Let's go back to oh wait. Chin strip not yet set. So yeah, we have a point to develop still, which is the it's that last one we were looking at, the outer bottom snout. Let's just make that very similar to the nose bottom, but it's going to be way further back. We can actually just make it 0, and then the Y is going to be, let me keep the Y the same, but make the X bigger. Okay. Now let's see. There we go. Okay. So we have, you can sort of see the foxy look now. And we have a bit of randomness just on that top polygon. So now we need to add some randomness to the color and the structure. Yeah. Let's first take out that red just to get everything a little bit more consistent. Oh, fuck it, let's leave it in. Let's work on the point randomness first here. I'm not really happy with the amount of code that's here just to get one random point. I feel like I could do a list.map. I could define some bounds and do a list.map. Or like a list of bounds and map over it and get the list of results. But then I'd have to put them into variables and pulling in Elm pulling variables from lists. I'm going to deal with maybes. Hmm. But we already have results. Maybe we could just have another error message or an error type, which is which sort of consumes that maybe. Well, let me commit this now because this is it's a good point to stop at. Ooh, I did a bad thing. That's supposed to be going here. Let's do this. Oh. Oh, yes, this then actually needs to go here. Oh, Jesus Christ. Wrong keys. Wait a minute. This is an interesting dilemma. What I want to do is put this up here. And then this up here. The problem is, if I do that, it's not a problem at this very moment, but that means that whatever I do up here, I can't actually use the template. But I need to have it out in this scope because I'm returning the remaining source here. I guess for now it's fine. Okay, we're back. And what we got here? Oh yeah, let's commit that. All right. So, I mean, I could just copy and paste this stuff and fill in all these, but that's going to be so much code. I'm thinking there's got to be a better way to basically request a batch of things. I'm thinking the way to do that is a list.map. So let's just try working on that. And if we make a, so what I'm thinking is, let's cut this from here. And then we want to make one for the inner temple, inner brow. Actually, if these, let's see if these are actually ordered correctly. Crown goes to temple, goes to brow. Just to make sure that crown, temple, brow. Yep. Nose bridge, nose top, nose bit. Yep, that is all correct. The ordering, anyway. So before going crazy on this list, let's just make sure we can make it work with the 1 point. So it's actually going to be a list.fold because we'll need to carry along the source. And really, let's see. And paying source. Was it accumulate? Was that map accumulate? Passing and returning the final value of the accumulator together with a new list. So that's what we want because the final value of the accumulator will be the remaining source. So accumulator is not, it's a bit misleading there, but that's what we're going to use. The accumulator is going to be the, let's see, F, C, that's A. So we need a function that takes the source and the list item and returns the new source and the transformed item. Map accumulated. And L just left, so from the left of the list. Okay, first argument is the function. Let's just put func there for now, we'll get there. And the initial value, which is source. And then the list, which is bounds list. And save that. It needs to know what func is. And func needs to take the binary source the bounds, turn the new binary source. So it's actually just, let's put that signature down. What do we want to call this? It's accumulating, it's reducing the source. Apply source, generate. Let's just call it func for now. It's not the best name, but maybe another one will appear. So again, this needs to take A, B, and A, turn into an AC. So the A is the binary source. B is the bounds, which is a, might as well actually just make this a type. Let's do this. Bounds. Correct. Bounds. Types. So okay, it's going to take some rect bounds. Then it's going to turn it into a new source and a point, vector 3. But it's actually going to be, is it going to be a result? Let's think about this. I think it's going to be result vector 3. Yeah. And the error is the gen error. Let's just see if it's happy with that. Gen error. Okay. And then point results, we'll define func in a moment, but let's first see if we can handle this correctly. So that's going to be, well, let's put a signature there. Make sure that results. This should turn out to be a list of result gen error vector 3. Let's see if it's happy with that. It is. That's good. Just to make sure it's happy, let's just put something in here. This needs some bounds. Let's just copy this back here just to see if it will compile. No, it's not happy. Oh, yeah. This could be a monster name, but that is a monster. Should say rect bounds. Is it? Oh, it is. But isn't that a rect bounds? List vector 3, vector 3. This is a list vector 3, vector 3, and yet it's complaining. That's odd. Oh, that's why. There we go. Okay. Okay, so that all works. Can I do a tuple? Let me just try this. No, can't do that. Can't do a type signature with a tuple. It's too bad. Anyway, but we do have a, let's do this. Actually, we can do this. Okay. So now we got this guy, which is a list of results with factor 3. Now, how do we turn that into to here? So let's leave that. Let's see if we can pull this from our list. Okay, that will give us a maybe result. How do we turn a maybe result into a result? Well, one first step will be to go to the gen error, which is maybe placed up here. So we're going to use that somehow. This get@, returns a maybe because it needs to be able to handle the case that the list is empty. So we need to turn a maybe this into just a this. We need to do that somehow by turning the maybe into a gen error. Right now it's maybe result gen error vector 3. That's what it is right now. I guess we could do a default. I think that's what we, yeah, that's what we do. Maybe with default. And then that one we just, okay, that works. And now if we define this function, we should be able to get the same behavior, or the same output, the same outcome, I should say, as long as we do this function right. source bounds, and then we need to return the remaining source and that, which will be a lot of this here. So source.consume vector from bounds with 2 bits per component. And then we say, oh, and you know, this could actually take a bounds, not to vector 3. So bound vector bounds. Bounds. Actually, we could just do this. Some error up here. Where's the error? Oh, that's not good. When the fuck did that happen? Okay, binary source is importing from types, which is not good. How do we solve this? This is always a tricky problem to solve. Oh, we could make rect bounds part of the vector 3. I think that would be the best way. Let's erase that. Go into types and take the vector bounds, take that out, vector 3, and add that here. Save, and getting an error here. So we just need to then go vector 3 dot. Okay, that's happy. All right, we have 2 sources defined. I just need to rename this. Let's just do S for now. I'm not sure if this code is really going to stay here anyway, but okay, now this takes, now it takes the bounds, right? Next one it takes is binary source. Now this should return a maybe, right? So we need to turn that maybe into an error. I bet that's what it's complaining about. So maybe you know, take that maybe and shove it in this second half here. I think we can do this with just with a default. Read out with default. If it failed, we're just going to return this original source and error of. And if we're getting a maybe, that means it ran out of source, so not enough source. That didn't. This argument is maybe vector 3. Oh. Yeah, this is returning things in the wrong direction. It's returning a vector binary source, and I'm treating it like it's returning a binary source vector. Now this signature we can't really change because that's going to depend on what map accumulate expects, which is that the accumulator, which is A, comes first. And I have a feeling there is a reason that I had it the other way in the other function, but maybe not. Maybe I could switch all those around. These all return the vector first, the binary source second, or the value first, then the binary source. Let's see if we can switch it all around. Let's see if that breaks anything. I mean, it will break something, but let's see if it breaks too much. Same thing here. Okay, nothing in here breaks. Lots in here will break. Wait, that's wrong. No, we want to return the binary source first. What's the problem now? This argument is, yeah, okay. It's probably a more concise way to do that. Probably have to do with the, let's just experiment with that. I think it's the maybe dot unwrap. The default in the function, yes. So the default is this, and the function is this. Yep, okay. Now, yes. Source is always going to be coming first. What was that called? Crown result. Oh, well, we can just actually, we can ignore this. This is going to be outdated soon. Really? Nothing else breaks? Yeah, I'm sure lots is going to break now. Come on. Yes. Tuple.map second. Okay. This could probably be cleaned up. I'm not going to worry about that now. Okay. Is anything else breaking? No. Okay, cool. So now, where the fuck was I? Yes, here. Okay, so if nothing's breaking, this should work now. Let's see what happens. Okay. Yeah, everything is still working. That's nice. It's a cool looking Fox profile. Yeah, just getting a gotcha bunch of color not yet defined, and that's great. Okay, that's cool. So now we can add bounds to this, and we can start doing this similar thing here. I might just want to encapsulate this in a function to make it a bit more concise. What are we doing here? We're getting it from a list, and then we're turning it into an error. So let's do this. I don't want to put this here. We're going to put this maybe in generate. So let's take this. Zero. And then generate. What was that? Or error. Takes int and a list A. It returns a result. Gen error A. Oh yeah, we need the actual, wait. Okay, hold on, let's back up. Indexed, index list. Hey. Oh, wait. This argument is list A. Oh, we need the list, right? Derp. Okay, still failing. This argument is maybe A, but it expects a maybe result. Ah, that's because this is list of result gen error A, I think. Yeah. Is that right though? No. This is a list of gen error vector 3, and we want to get a, oh, yeah, we just need to expose this. Not exposing everything, so generate. This is actually a util though. So let's keep that like that, and go down here, take this baby and put it in utils. Uh-oh, is types importing utils? That doesn't seem right. Oh, types is importing something that imports utils. Binary source. Yo, that's not pleasant. Okay. The thing is, this does belong in utils. Utils should be able to import types. Types should not be importing utils, I think. Types is importing binary source, which is importing utils. What happens if we take this out? Oh, nothing. Okay, cool. Then types is good. Utils is good. Nope, still not good. Need a list.extra. randomness. Okay, that's working now. So now we can, okay, now I'm ready to start adding stuff to this list. Now we should be able to start seeing some randomness. This could probably be cleaned up and generalized, but let's do that in a bit. Okay, so let's just get, how many do we need in here? We need 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Yeah, and now we need to start defining these. Just to make things clearer, let's do this. Okay, now we can start having some fun, I think. Let's also just propagate this. Let's make this happen for all of these. I'll just change the number too. I don't think we really need these values right now. Let's just delete them and go like that. Let's go 1, 2, 3, 4, 5, 6, 7. Let's start changing these up. Okay. Maybe for readability we can do like this. Is that going to work? That works. Okay. Except for now these are all the wrong spot. There we go. Cool. Inner temple. So, looking at the demo now, no, the demo hasn't been refreshed yet. So the temple is this first point here. And how do we want to randomize that? Let's try basically doing the same x, lower y, higher z. So same x range, lower y range. So this is where it gets tricky because I'd like to be able to reference this here, but I think to do that I'll have to make a whole new transform, make another item in this big monster list here. So rather, let me just get more careful with the ranges. The x range, that can change the same way. The y range, it needs to be lower. And I guess it's okay, well, maybe it's okay if the inner temple turns out to be higher, but it should tend towards lower. So if this is 0.4 to 0.7, let's make this 0.2 to 0.5, or maybe 0.3 to 0.5. Let's just see how that works out. That should at least be able to draw the crown. Let's save that and then see what happens upon a refresh. Okay, so these are the temples. That does not seem right. Something seems wrong there. Well, the z needs to be different, right? The z needs to be quite a bit more forward. Let's say 0.2, whoops, not there. 0.2 to 0.4. Okay, those are looking a little bit more like temples now. That one is weird. That is a misdrawn polygon. Why would that be happening? This one's also just empty. Okay, let's color things differently. To see what's going on here. Let's say crown is red, temple. Let's just see what that will do. Oh wait, temple is not the right one anyway. Temple should be, temple is this should be the forehead, I think. There we go. So here, these ones all are on the same plane. They also go back. We could we could define this relative to this one, and then in here we could add them. Crown point, inner temple. I guess if we have a crown and a temple, we do know that the temple should be sort of a little bit more forward. We do know something about the relative relationships. Let's try doing that. So relative to the crown, we want it to go and this is tough because then what do I do with the x value? We would like it to go inside if possible. But if the temple is 0 and it goes negative, it's gonna fuck shit up. Could just decide that the temple is never smaller than the crown. Let's just try that for now. Okay, whoops. So it's either as wide or wider than the crown. And then the y is definitely going to be, let's say, 0 or less than the crown. So this can be a negative 0.2. And the z, we definitely want it to be more forward. So it's going to be, yeah, so let's say 0.2 to 0.4. Save and see what, oh, and then we need to actually treat it like a relative point. Inner temple. So we get it there. Now we're going to result.map. To, let's do this. Result.map to this comma here. It's our first argument, and then our second argument be a similar one. Actually, that's our okay. So we're result mapping to. So now we have 2 points. We can just add them. In fact, I think we can actually just directly call 3 dot plus. Okay. Still a bit fucked up, huh? Why is this fucked up? Let's get some debug happening here. Okay. We have a ix, iy, low z as the, so this will be for this first one here. And the second one is 0, 0, 0.2, so it changes the z. What the fuck is going on here? Okay. Oh, wait, am I using the wrong points? Crown, inner temple. Oh, that's why. I haven't defined the second point yet. Duh. I need this third point to make these two polygons, and I didn't do anything here. Right. Let's try this. Okay, the brow should be basically just lower than the temple. And how do we want it to, how do we want the temple? So we're talking about this point here. It can be wider, it can be narrower. I guess we want to minimize it at 1. No, we don't want to minimize it because that could erase some entropy. Minimize it at 0, that is. For now, let's make it the same. Make the y a little bit less. Negative 0.1 to negative 0.3. And the z, let's just keep that the same too. And then let's go do the same thing. Gotta say, this is not turning out as elegant as I really wanted to. We probably don't need this anymore. Let's just take that out. And then this will be 1 and 2. Okay, that's looking a little bit more normal. I mean, it's still pretty fucking weird. Let's tweak these points a bit. It's hard to really visualize what's going on without the rest of the points. Why does this come to 0? Didn't I not change the x? Okay. Oh, I'm also not coloring. Oh, I shouldn't be. This is slower going than I thought, than I hoped. Maybe my problem is I'm trying to fit this all into one transform here. Yeah, I think so. By putting them into one transform, it's getting hard to define points relative to the previous points. I'm trying to bend over backwards to like make relative points now and then apply them down here. What if each transform just made like one set of points? That might be better. Let's just try that. Save this. Let's just get 1 point. Oops. What? Oh, crap. Yeah, and then let's just make another one. This is probably the better way to go. I was chasing the wrong rabbit. Yeah. But again, here I can't reference the template anymore, which is where the shit is stored. Hmm. Huh. Well, once again, I can make this a relative vector and add it to the thing up there. Hmm. I'll have to take a break and think about this one.